Hi friends, a very good evening and thank you for joining in. Could you please confirm in the chat window if everything is working as expected? I'll just check everything on my phone. Again, if you're not able to see the chat window, you can always refresh the page and you'll be able to see it now. Just let me check if everything is working. Okay. Yeah, I can see myself on my phone, so hopefully there are no glitches. Good. Okay, sounds good. So yeah, I got a little delayed by a couple of minutes today. I typically try to join a few minutes early and I'm a little delayed, but let's get started then. What we'll do this time is, since it's anyway 7:01, 7:02, let's dive into the session itself. As usual, I'll spend a good amount of time at the end answering your questions, okay? So probably we should be able to finish the questions in about 1 hour. I'll spend about half an hour at the end trying to answer your general questions, okay? So can you just confirm if you can see my screen? Can you just confirm if my screen is visible? Let me also check it on my phone. Yeah, I can see it on my phone. Yeah, cool. So today it's a very interesting topic with respect to operating systems. Is my audio clear, or do you want me to increase the gain or anything like that? Let me just check. Okay. Yeah, probably this will be slightly better. Okay, cool. Okay, so with the audio issue out of the way, so this is the third live session on operating systems. This is a public live session and we'll focus on interprocess communications, concurrency and synchronization. Bunch of interesting questions. As usual, we'll have a mix of easy questions and a few medium, few tricky ones, right? So let's get started with an easy question first. Okay. I hope the question is clearly visible. Again, please focus on answering these questions and tackling them. And I promise you, we will surely spend time at the end of the discussion for general question answering, as we always do. Again, our mentors also will answer some of the questions via the chat window. Again, let's focus on solving the questions. We'll surely answer general questions at the end for sure, as we always do. Please take your time, think through this carefully. Folks, please focus on solving the problem. We'll spend a good 30 minutes at the end answering general questions for sure. Again, it's an MSQ, as many of you know. This is an MSQ, which means multiple options can be correct. This is a 1-mark question. Please be careful. Read the question carefully. Think through it carefully. I see some of you who have put in your answers in the chat window. Please review them once. Some of you may have not read that it's an MSQ, probably got confused. This is a simple one. If you know basics of how concurrent execution of processes happen, this is fairly straightforward question. I'm hoping and waiting for others also to answer, because this is like a warm-up. Cool. I think most of you got it right. This is a fairly simple, literally a giveaway problem. So let me answer this. So we have two variables x and y. which are shared variables shared by both these processes, and they're initialized to 0 and 0. Now, you have process A and process B. The question says, what could be the output of the concurrent executions of process A and B with X and Y as shared variables? Very simple. Look at this. Initially, while X equals to 0, do nothing, which means as long as X equals to 0, we can never go below this line, right? Because we'll be stuck in this loop. So again, there will be preemption because it's a concurrent execution. For some time, this process will execute, then this process will execute, and things like that. So when this process is executing, first we'll print B. That is obvious, right? So we have printed B. After printing B, again, if the process gets preempted now, and if the execution is given to process A, it will still be stuck because X is still 0, and it will still be in this do nothing loop, right? But let's assume X equals to 1. After X equals to 1, this loop can be terminated out, right? So after X equals to 1, you can start executing these lines, right? Now, okay, so one possibility is you print B and then X becomes 1. Then you printf A, cool. Then you printf A. Then after this line, let's assume there is again preemption. You have to think of all the possibilities, right? Now your execution is here. While Y equals to 0, do nothing, right? And Y is initialized to 0. Till now Y hasn't been changed, which means this is also going to get stuck in this infinite loop till the time Y equals to, till Y equals to 1. Now here look at this. If Y equals to 1 is executed, and then we come to this, like for example, if this line is executed, this process is preempted, and then this process gets executed, then we'll come out of the do nothing loop, right? And we will be able to execute, we'll be able to print C. So one possibility is we get preempted after this line, Y equals to 1, so that C gets executed. After this, process B is over, then we come back to process A, Y becomes 0, then we printf D. So BACD is one possibility, which is option C. This is one possibility, but there is also another possibility because preemption can happen at any time. We don't control that. It's the operating system which controls that, right? So it could also happen that we printed B first, then we printed A. Then look at this, we printed this, X became 1, so we printed A. Now if let's assume Y equals to 1 and Y equals to 0, both of them are executed. If both of them are executed, and then at this point if preemption happens, now this line, still Y equals to 0 here, even though this line made Y equals to 1, we did not give control to this process. We gave control only after Y equals to 0. So what happens now is this Y equals to 0, it's going to still get stuck in this do nothing loop. So it now, while it is stuck here, preemption again happens, then printf D will be printed. Finally, there is Y equals to 1. This is what will help us get out of this infinite loop, right? So when Y equals to 1, you can print BADC also. So both B and C are possible outputs. Again, this is like a simple warm-up problem. Anybody who has done any sort of concurrent execution, understanding how things work, this is straightforward, easy 1-mark MSQ question. Simple. Okay. So with a simple warm-up question, let's go into a slightly more interesting question. Okay. So here is, here is the question. This is a 2-mark question. This is an NAT. So this is our second question. I'm happy that first question most of you got it right, which is good, which is also encouraging because it's an easy one. This question you have to think a little more than the first one. So Mayank, your question is interesting. So just please post it at the very end. I'll surely answer this, right? I don't want to disturb others who are still solving this problem. I'll surely answer your question. Please don't forget to ask this question about multiple options that you're not sure of. Please ask it at the end. I'll answer that. Please think very carefully for this question. This is a good 2 marks question. I know a lot of you would make mistakes here. Please take time, think through this. You have to think from first principles for this. You have to think little carefully. if you know the basic concepts of concurrent execution, how actually something like this is executed, if you know how it is done, this is straightforward. But I see some of you still getting mixed up, so think about it carefully. By gate standard, this might be called a medium, but I would personally call it easy if you know the basics. Good, very happy to see some interesting answers from you. Good, good, good. I'll wait for a few more seconds because many of you have answered it correctly. So let's wait for a little while. It's okay. Other, if you're not able to solve it, try to think what's happening. Try to think from first principles. I'll give you a hint. Think how this would be broken, because think how this would be broken into individual commands, right? Like computer organization commands. Think from that first principles perspective. Okay, I see a little variability in your answers, which is always good, because that gives me more pointers on where students are making mistakes and I can help them correct it. Okay, okay, so let's go into this, right? So how would this simple line actually get translated, right? If you know how, if you have studied compiler design, or if you have studied computer organization, or even operating systems, right? There will typically be a load here, wherein you load whatever value is there in XYZ into some register. Let's say you'll load X, so there will be a load, there will be an add, there will be an add command where you're going to add whatever value you have loaded, you're going to add 10 to it. Then there will be a store. Right? So this will internally be executed as a sequence of 3 instructions, right? Three computer instructions, right? There will be a load instruction, add instruction, and a store instruction. Similarly, this will also be a load, a subtract, and a store. This will also be a load, a multiply operation, and a store operation, right? Of course, typically what happens is, suppose, let me just write this, right? So this will typically be converted into load into some register R1, whatever is there in the variable XYZ, and then it will say, hey, add, right? Whatever is there in R1, I mean, it could be depending on how many address modes it is and things like that. You can say add to R1 some constant 10, right? And then you can have something like store whatever is there in R1 in XYZ back. Right? I mean, I'm not writing the actual assembly level code of any specific architecture, but roughly speaking, this is what it would get translated to, right? This R1 is basically a register in the microprocessor that you have. So remember, the interesting aspect here while solving this problem is, what could happen here is this could load, because these are 3 instructions, right? So what could happen here is, after P1's load, right, it probably, let's assume, loads it into some register R1. After it executes the load command, there could be preemption that happens here, right? And P2 could execute load, subtract, and store, right? So if you think about atomicity of execution, typically what happens in most modern microprocessors is each instruction will get executed, and then there will be a preemption that happens after that, right? Typically. So this is internally translated into a load, add, store. This is load, subtract, store, load, multiply, store. Typically that's what it will be. So of course, there will be some inconsistencies, some crazy things that will happen, because after load you could be taken out. But if you think about it logically, right? So suppose if you want both minimum value and maximum value, that's what we want, right? We want to take the minimum values and maximum values and subtract them so that we get the maximum absolute difference. That's what is being asked of us. Now, if you think about it, how do you get the minimum value? See, subtraction, so how do you get the minimum value? One way you can get, again, addition basically increases the value of XYZ. Multiplication also increases the value of XYZ, given that XYZ initially has 100. Let's not forget that. What is there within XYZ is a positive number. right? So addition basically is going to increase it. Multiplication is also going to increase it. Now, if you want the minimum value, okay, the only way you can reduce this 100, because you want to reduce it as much as possible, is through the subtraction operation. So one way this can happen is this. Let's assume P2 runs its load first. So P2's load, okay. So what is P2 loading? Let's assume P2 loads this 100. So let's assume P2's load executes first. So this executes first. So what happens now? Let's assume P2 is loading something into register 2. So in register 2, it has loaded value 100. Now after this load, let's assume there is a preemption that happens. Some preemption has happened. Then P1 executes. Okay. So after this, let's assume P1, the whole P1 executes. Let's assume P1 is using some other register R1. Right. So P1 is using some other register R1 and it executes this. Okay. So what is it writing back? So P1 will result in a value of 110 in XYZ. Let's not forget that. Okay. So P1 executed. Let's assume P3 also executes. Whole of P3 also executes. So P3 will load this 110. It will multiply with 2. So P3 will store 220 to XYZ. So P1 is finished. P3 is finished. Now P2's only load is finished. There is still subtract and store. But remember that P2 has already loaded the initial value 100 in a register 2. Now when it has to do subtract, it will subtract this constant 20 from this value 100. So it will subtract minus 20 and it will be 80. This 80 is what it will store back in XYZ. Right? So what happened here is whatever increment, whatever increase that has happened because of P1 or P3 is completely nullified. Because P2 loaded this value at the very beginning, it kept it in a register, right? And then it subtracted this at the end and stored its final value. Now you will say, hey, this is inconsistent. Yes, it is inconsistent, no doubt about it. Okay, the result that you're getting XYZ equals to 80 is an inconsistent result. Yes, it is. Okay, but that's what will happen internally if you have these three processes running these three commands, all three of them parallelly operating on XYZ without having some mutex. Okay, without having some form of locking mechanism. If they do it, this is what will happen. So the minimum value you can get is 80. What about the maximum value? If you want to maximize the value, you don't want the subtraction to happen in the first place, because subtraction is a form of reduction. If you want to maximize, you want to add first and then multiply. Simple logic, right? So if you want to maximize, one thing you can do here is this. Let's assume okay, so you can do this. P1 executes first. Okay, so P1 executes and P1 stores, let's assume 110 in XYZ. Cool. Then P3's load operation will execute. Okay, let me show you this. P3's load operation, let's assume, is loading into some register 3 this 110 value. Okay, so only P3's load has executed now, right? Then let's assume whole P2 will execute. What is P2 doing? P2 is subtracting 20. This will result in XYZ having a value of 90, right? Because it's loading 110, which is the current value of XYZ. It's going to subtract 20 and it's going to store. But this 110 value is already there in register 3 that P3 already has loaded, right? So now P3's multiplication and storing will be executed. After P1 is finished, P3's load is finished, P2 all the 3 instructions over, then P3's multiply and store will get executed. So what will it store now? It will store 220. This is the maximum value you can store because you did not subtract anything. You're first adding and then multiplying. That will be the maximum value. So the maximum value is 220. The minimum value is 80. So the difference is 140, right? So yeah, the minimum, yeah, it's 140 plus 80 is 220. That's right. Yes. The answer is 140. Simple, right? So this is how the internally things will get executed. There is no synchronization here. I mean, there is no way you're controlling access to this variable XYZ anywhere. Right? I mean, all three of them can jumble between. So there will be a lot of inconsistencies. That's the reason why we have locks, right? That's the reason why we have something like a mutex in the real world, right? This question is not time consuming. I just took more time to explain this to you because when I solved this question today, probably in the afternoon, it took me about 2 to 3 minutes to solve it. It's not lengthy. It just took me more time because I wanted to go into the specific details in more thoroughly. Okay, cool. This is easy. By the way, this is while some of our mentors who have studied gate questions in much more detail think that it is medium level by gate standards, it's actually easy. Of course, there might be other variations to solving this question, but it is always better to think, because this question can be twisted. This question can be made tricky by changing these operations or by adding more complexity. Instead of one instruction, instead of one addition, you could have an addition and something else. So it's always helpful to think in terms of how this would get translated into individual load, store, and whatever arithmetic operations. It's important to think about it from the first principles approach, because that will help you solve even if the question was trickier, right? This is like a medium level. It's not at all tricky. It's straightforward. That's why most of you got it right, which I'm very happy about. Okay, cool. Again, there are some general questions that I see in the chat window. I'll surely answer them at the end of the session. This is a slightly more interesting question. Okay, for those of you who don't know what is a laundromat, again, this is a question I believe from a standard textbooks with some modifications. A laundromat in most of Europe and US is you have a bunch of washing machines in this laundromat, or a bunch of laundry machines. You go, you put a dollar coin or whatever, you put some money into this, it will give you access to this machine. You can wash your clothes, take it away. This is like a central store where there are a lot of washing machines in which you can wash your clothes in case you don't have a washing machine at home. That's what is a laundromat. Again, this question, please read it very carefully. Please be very careful with this. You will encounter these types of questions which are slightly lengthy to read. So this is a good 2 marks question. It's an MSQ. Again, our mentors are answering some of the follow-up questions you have. I'm also thankful to some of the students who are putting in their other answers, right? Again, please avoid general questions because we'll answer them at the end, as we always do. Yes, somebody saying, do we expect such long questions? Yes, there are years in GATE question papers where question papers are lengthy, where it will take you time to read what's happening. The question itself may not be hard. No, please don't leave this. This is easy to tackle. Please don't leave it. Long questions do come. I've seen this firsthand. When I wrote my GATE exam in 2006, there were lengthy questions from operating systems, computer networks, databases. Yes, you can expect them. Last year also, I think set 2 was a little lengthier and trickier than the set 1. Again, try to give it a quick read. Oftentimes, as you will see, questions which look lengthy tend to be also easier. Not always, but sometimes. The lengthiness is only a way to confuse students to give up on the question before they even solve it. So read carefully, it should be easy to solve. Again, for those of you who don't, okay, this is already mentioned, right? Okay. P here is like your wait signal, right? In semaphores. V is like your, P is like your wait function. V is like your signal function. Just in case you're confused about it. Okay, again, my problem is I have only one screen to show everything, so I'm not able to zoom in, because if I zoom in, others who are reading the above part might miss out. Okay, let me see how it looks on my phone quickly. Yeah, I'm able to see it on my phone comfortably. I'm able to read the code also on my phone. So again, I'm just checking it on my phone to see how it looks. Another thing that you can do, because I want to have the whole question, this is in full screen, I believe, right? Almost full screen. Let me see if I can, zoom, again, it will not change it a lot. Yeah, little increase that I could squeeze in. Yeah, that's the max. Beyond this, I think it will come crashing. Again, this is an MSQ, so think about it. Another suggestion that I can give you is take a screenshot of your laptop, or on laptop I don't see any issues here. If you're watching it from phone, take a screenshot and zoom it in. That's another suggestion I can give you. These questions are typically taken from standard textbooks or from assignment problems at top universities. Please understand that very often, in a vast majority of cases, lengthier questions tend to be easier, or they might be a small trick that if you get it, you're done. I like this question because it's putting you into a real world situation and asking you to think. Soham, please put your question at the end because it's a general question about preparation strategies. I'll surely answer it at the end. Those of you who have answered it till now, right? While the question was lengthy, do you think it was easy or not? Feel free to tell me in the chat window. The question looked daunting at the beginning, right? But once you solve it, did you think it was easy or not? Like, by GATE standards, this would be called medium. Good. Aniket has a very nice thing. He says this question was easy, just that the story was big. Good one. Yeah, a lot of these story-based questions tend to be slightly lengthier to read. But please don't, as somebody is saying, please don't skip reading the story part, which is this paragraph, because that will give you a real world context in which you can think about this code. Otherwise, if you directly go into the code, you'll get lost, you'll probably miss something. So please don't miss it. I have a follow-up question. Those of you who think there is a race condition here, those of you who think so, how do we avoid the race condition here? Any thoughts? Just a follow-up question. Think about that also. Those of you have already answered, right? While others answer it. Those of you who think that there is a race condition here, how do we avoid the race condition? Can you think of a simple solution for that? Just a follow-up question. Interesting. Like something like this, I mean, if somebody for a software engineering interview says, hey, operating systems is my favorite subject, an interviewer at a top product-based company, if he or she is also very strong in operating systems, and if their team actually builds really critical stuff, they might actually ask you a problem like this and say, hey, how do you solve this problem using semaphores or other schemes. Okay, so cool. Many of you got it right, which I'm very happy about. So let's get into it. This is the whole story. I'm sure you all would have read it. So basically what we have is basically you have this array called available, right? You have this array which is a Boolean array of trues and false. Everything is initialized to trues, right? And you have this counting semaphore which is n free, which is initialized to n machines, right? So this is the initial setup that we have. Now we are given some code. Okay, so let me just, okay, so the way I always think about P and V is P is equal to the down, right? Like you're going to decrement it. V is like up, right? Or wait, I mean other terminology in some books is wait and signal. Now let's see. So what we have is a counting semaphore, because your n free is a semaphore, right? This is a counting semaphore. So let's look at, first let's read the question, let's go through the code. So you have a down and there is this for loop where they're checking for the first available machine and they're going to pick it up. So in the release, okay, they're just going to make whatever machine they're using, they're just going to make it true and they're going to increment this n free variable. Basic stuff, basic semaphore, basic counting semaphore stuff. Now let's go through the 4 options. Does it have a race condition? Now what does race condition mean actually? Race condition is if you have multiple processes or multiple threads that access the shared variable at the same time. So okay, I don't want to write the whole thing, but in short it means multiple threads or multiple processes can access, okay, let me write it quickly, can access some shared variable at same time. Can that happen? Can that happen? It can, right? Because your available array, this Boolean array available, is a shared variable. It's going to be used by all the threads or all the processes, right? So there is a race condition that you will run into because, look at this, imagine, let me give you a simple example. Imagine initially you have 10 laundromats, right? Or 10 laundry machines, right? Initially, let's assume the n machines is 10, let's say 10. Suppose there are 2 processes that both come in, that, like suppose imagine 2 customers go to 2 machines and they say, hey, I want you to assign me a machine, right? So what happens is at the very outset, all these machines, machine 0, 1, 2, so on and so forth, 9, all of them are true, all of them are available. So the first guy who comes, he says, he first checks this. Now after you have created this down, what happens is your n free, the first process will decrement this to 9, the second process will also decrement to 8. So both processes now are in the same for loop. Now it could so happen that if you look at available 0 now, look at this, available 0, right? I mean, because of how preemption can happen between processes, because the number of resources that you have is 10 and it's not a binary, right? It's a numeric, it's a counting semaphore. So both of them decreased it. One of them got the value to 8, 9, the other one got the value to 8. Now this available 0, this first one, both these processes or threads could be accessing available 0 simultaneously, right? Right? It could so happen that they can get into a crazy race condition where both of them are racing to acquire this 0th number, because both of them could be accessing this variable and checking if they are true almost simultaneously. So there is a race condition here because multiple threads or multiple processes are accessing the same shared variable which is available 0 here. The whole available array is shared, and that's happening because your n free is not a Boolean semaphore or a binary semaphore. It's actually a counting semaphore. That's why you're able to get in. So there is a race condition for sure. Now, before we go into deadlocks, because one of the interesting things that we know about deadlocks is, I mean, what are the conditions that you need for deadlocks, right? Deadlocks require mutual exclusion, right? So it requires mutual exclusion. Deadlocks require something called as a circular wait. Again, this is basic concepts of what are the necessary conditions for a deadlock, right? It also has the requirement that there should be no preemption, and it also needs that at least one resource, okay, some resource is available that is held by somebody and things like that, right? So for a deadlock, a mutual exclusion is a must. So there is also an option here which talks about mutual exclusion, right? So let's think about mutual exclusion, because by answering this, we can think about deadlock, because for a deadlock, there should be a mutual exclusion. So let's think about mutual exclusion. Option D surely is wrong because there is already race condition, right? So let's think about mutual condition here itself. Let's think about mutual exclusion here. Now, as you all know, right, this is actually a counting semaphore. In a counting semaphore, if you think logically, right, a counting semaphore has no mutual exclusion, right? If you think about it, this is sort of like the critical section of your code, because you're actually giving access to the resources to one of the processes or threads, right? There is literally no mutual exclusion because this n free could be a number like 10, and by different processes, as long as it's greater than 0, they can get into this critical section where resources are assigned. So there is actually no mutual exclusion, right? Because simply, again, this is a problem of the counting semaphore. As we have studied in our course videos also, if you have a counting semaphore implemented in this fashion, you don't have mutual exclusion. So C is also correct. And if there is no mutual exclusion, how can there be a deadlock? So deadlock can't exist. So this question, if you think about it, is actually fairly simple. If you know the definition of what is race condition, what are the necessary conditions for deadlock, what is mutual exclusion, I mean, this question, there is all this kahani or story or kada, depending on what language you're, whatever is your mother tongue, right? There is so much of the story, but the logic itself is fairly simple, right? Now the follow-up question that I asked here is, how do you avoid race conditions? As many of you suggested, one simple way is to use a mutex, right? A simple way is to use a mutex. Again, a very common question here is, what is the difference between a mutex and a binary semaphore, right? So somebody might say, hey, I can just use a binary semaphore. Not exactly. A mutex, again, they're used for different purposes. A mutex internally probably is implemented as a binary semaphore, but a mutex has this very interesting property. Mutex is like a lock, right? So whichever process locked, only it can unlock. That's the key aspect of a mutex. Oftentimes in real world operating systems, mutexes can be implemented, are often implemented using binary semaphores, except for the clause that whichever process logged, only it can unlock. So one simple solution to avoid race condition here is like a race is through a mutex. Here is a simple code snippet that you can do here, right? So again, small change in code. If you see, hey, there is a mutex, so you're basically acquiring the mutex here, right? Look at this. So you're creating this mutex called available mutex, okay? Which is a mutex, nothing but a lock at the end of the day. Right? It's a binary semaphore with the same process having the ability to unlock and lock. So you have this n free. Again, this n free is a counting semaphore. It's a count semaphore, right? That's perfectly all right. This count semaphore is going to tell us how many resources are still available to us. But this mutex here, again, we are using this mutex to have control on this, because this is the critical section where resources are being actually made available. First, you are checking if a resource is available and then assigning it to it. Right? And then you can release the mutex here itself, right? You are acquiring the mutex here, you are releasing the mutex here. So a small code change like this could help us avoid the problem that we have, which is race condition in this case. It's simple. Again, this also has mutual exclusion, right? That's it by definition. Mutex provides mutual exclusion because if one process is inside this, the other process can't get into it by definition, right? Cool. So again, just wanted to show you a small variation of this. Okay. Cool. Okay. So again, one quick point I wanted to make was, okay, let me just avoid the full screen. It's little, 1 second. Just give me a second. Okay, cool. I'm just putting the Google Docs in full screen. Okay, so very often whenever you see a question like this, please don't panic, just read it carefully. Very often lengthy questions tend to have maybe a little trickiness here, right? Again, this is not hard at all. If you know the basic properties, if you have studied simple process synchronization, locks, right, semaphores, etc., this is straightforward. So don't worry about it. Again, we just wanted to show you a small interesting update to this snippet of code. That's it. Cool. So let's get back into our original thing. Cool. Let's get back to question 4. No, mutexes and binary semaphores are not the same, at least to the best of my knowledge. somebody saying mutex and, okay, let me just make a point there. Mutexes and binary semaphores may be implemented internally very similarly, but their purpose and how they are implemented are slightly different. This is an MCQ, yes, unless otherwise stated, questions are MCQs. This is a 1 mark question. This question is all about knowing the definition of what a deadlock is, what is bounded waiting, what is progress. If you know that, you're done. A counting semaphore with one resource is like a binary semaphore. It's not like a mutex. There is a subtle difference between a mutex and a binary semaphore. I'll wait for a little time. Again, a binary semaphore versus mutex, you can just Google search for it. I'm sure people would have answered this question at many places. Okay, so let me get into the solution here. This is a simple 1 mark question actually. It might be a little tricky to make you fall into a trap. First, let me go into S2 because it's the easier of the options, right? So what does S2 say? Does deadlock imply no progress? Yes, because what's happening in a deadlock? Everybody is getting stuck. Nobody can get access to resources anymore, and there is no progress that is happening, literally. Again, you can use the official definition of what a progress is. Again, what does progress mean? If no process is executing in the critical section, and if a process wishes to enter into, again, there is a proper definition to progress, right? But even if you think logically, bounded waiting is what is more trickier, right? So when you have a deadlock, there is going to be no progress that's going to happen because everybody is stuck, literally. So S2 being true is easier to observe. S1 is a slightly trickier option because a lot of people get confused with bounded waiting, right? So just give me a second. So in bounded waiting, a lot of people think that bounded waiting is with respect to time. No, the actual definition of bounded waiting is, it says that there is a bound or a limit. So what it says is that there is a bound or a limit to the number of times, I'm just writing it in short form here, to the number of times that other PIs, right, are allowed into the critical section, before our process. Let's call our process P star, right? P star's request is granted to enter into CS. Request is granted, right, to enter CS. So this is the actual definition of what bounded waiting is. This question is all about, again, the key important thing here is bounded waiting is not about the time duration, because in a deadlock you're completely stuck, right, which means you're going to keep waiting for whatever time. But bounded waiting basically says that there is an upper bound or there is a limit to the number of times that other processes are allowed into the critical section before my current process request is granted to enter into CS. It's a number of times that there is a bound on. Imagine that the bound is, let's say, some 10. I'm just making it up, right? Imagine we are in a deadlock. So this is a slightly tricky thing. Suppose imagine we are in a deadlock In a deadlock, what's happening? Everybody is stuck. No process is moving forward, which means no process is actually getting into the critical section itself. Every process is literally stuck. No process is getting into the critical section, right? And every process, after we enter into a deadlock, how many times did other processes enter into the critical section? 0 times. They entered into the critical section 0 times. And we have a bound which is 10 times. So this definition, this actual definition is still satisfied. That there is, we don't have a bounded waiting. We have a bounded waiting, I'm sorry. So deadlock, so the key here, so the definition basically says there is a bound or a limit. Bounded waiting basically means that there is a bound or a limit to the number of times that other processes are allowed into the critical section. If you have a deadlock, no process is going to enter, which means every process would enter only 0 times. But imagine if I have a bound of 10, till the time this bound is reached, I cannot complain that my current process P star is not being let into the critical section, because this bound itself is not reached, because we are all stuck literally. So from this actual definition of bounded waiting, this statement is false, or in other words, to be more precise, with deadlock. So let me write it. With a deadlock, if you are in a deadlock, if in deadlock, you can have bounded waiting. You can have bounded waiting. We have bounded waiting here as an extreme case, right? You're stuck in a deadlock, your bound is, let's say, some 10. But nobody is getting into the critical section, which means till the time we get out of the deadlock, we can't complain that we are not being let into our critical section. So if in a deadlock, you can have bounded waiting, which means option S1 is false. So S1 is false. Which of the following is correct, right? So S1 is false and S2 is true. So option A is correct. Again, this is all about this definition. Lot of students, this is a very common confusion. That's why I think this question was also designed by one of our mentors, that people get confused that bounded waiting is about the time duration. No, it's about the number of times that other processes are allowed into the critical section before our process is granted entry into CS. That's the catch, right? Except that I think things are straightforward here, right? Cool. Deadlock basically implies no progress. That's obvious, right? So cool. Yes, so this is called strict alteration. Yeah, this is an example of strict alteration, as one of the students pointed out. Yes, that's true. Cool. Cool. So again, bounded waiting is an important concept that you have to be a little careful with. Again, the definitions for all these concepts, right? The most important thing, whether it is for progress, whether it is for deadlock, whether it's for bounded waiting, whether it is for starvation, please read the definition correctly. That's the most important thing. For example, I would recommend, Wikipedia has been my, we're talking about bounded waiting, right? Bounded waiting wiki. Okay. Bounded waiting wiki. Okay, let's see. In Peterson's algorithm, is it mentioned? Okay. Okay, so it's also called as bounded bypass. Okay, where is it? Do we have a formal definition of it? Liveliness. Okay. Yeah, I think this is a reasonable definition. Bounded waiting or bounded bypass means the number of times a process is bypassed. Look at this, the number, same logic, right? The number of times a process is made to wait or bypassed by another process that it has indicated desire to enter into critical section is bounded by the function of the number of processes in the system. Cool. This is cool. This is the more mathematical definition, because it's saying, hey, this bound has to be, again, that's an important thing that I forgot to mention, that the bound that we have has to be a function of the number of processes that you have in the system. Some function. In our case, what is that function? That function is, like, I can make this function a constant, right? So I said the bound equals to 10, right? I can make it a constant like this. That's what I did a while ago. But this is a more rigorous definition of what bounded waiting or bounded bypass is. Similarly, for all concepts, right, I would strongly recommend you check out Wikipedia, which has tons of, again, I really love some of the code examples that they've given here. We have also explained some of these code examples in our course videos, because I really like Wikipedia tends to have most of the details, most of the times correctly. Cool. With that, let's go to the fifth question. This question is slightly lengthy. Can I squeeze this in? Okay, I'll move this to the side a little. Okay, cool. This is an MSQ. Again, some of you are asking questions about other aspects. Please check the course videos. We've explained it in a lot of detail with lots of examples and boundary cases. Again, we may not be able to explain it in a live session, because to explain all of the cases and why we have these necessary conditions, why this means that and not the other way around, we've explained all those examples in the course videos and problems. And I mean, this chapter is one of the lengthier chapters also in the GATE syllabus of operating systems. So it may be hard for us to justify all of it via a chat window or in a live session like this, which is meant for problem solving. There is a small probability that some of the Wikipedia information is wrong, but it's a very small probability. I found it maybe just only once till now in a machine learning or a statistics article. Again, any course enrolled student, beyond what we are explaining in these short videos and in the chat window, please feel free to cut a ticket. Any follow-up questions you have about the examples or other cases, just cut a ticket and we'll get back to you as soon as possible. Just like Wikipedia, there is another problem. Standard textbooks also have some variability in the terminology in how they describe. So you have to be careful there also. So for all of our course enrolled students, we have created this framework where we have a ticketing system where they can just ask their queries instead of email, because email is harder to manage for us. And also for students, they can just ask their question and say what topic is it, what chapter it is, and things like that. And it's directly assigned to one of our mentors who can answer it faster. That's what is it. It's in most tech companies, this is called a ticketing system. So that's what we have for all of our course enrolled students. Anyway, back to our question. Sorry, I got deviated. I don't want to disturb the students who are solving this. It's an MSQ, right? Okay. This is a 2-mark question. So just FYI, the ticketing system is only available for our course enrolled students. And for a test series enrolled students, it's limited to the test series questions. We'll try and answer as many questions as possible. Of course, we prioritize course enrolled students first, and then the test series enrolled students, and then the general public. We try our best to accommodate as many as we can. Cool, I'm happy most of you are getting it right. This is a simple problem actually. This is actually easy. Again, please read it carefully. Which of the following is incorrect? Kalul, you're right that sometimes we set questions which are slightly trickier, maybe a little harder than PYQs or previous year questions, because we want students to prepare for a hard paper so that they're not surprised by something crazy at the end, right? It's better to prepare for a slightly harder paper. Cool. Let me answer this so that we can spend good amount of time on the in general chat or general Q&A. This is very simple actually. P basically means down, V is basically up. That's how I remember it. Okay. Some people might remember it using their Dutch names. Some people also remember it as weight and signal, right? So you can just draw something like this. This was drawn by one of our team members. So you have sequence 1, right? So what is sequence 1? Sequence 1 was this, isn't it? Just a second, let me check. Sequence 1 was AA, BAB. Okay, cool. So this is sequence 1 and this is sequence 2, right? So this is our sequence 1. I've just taken the same diagram from, this is sequence 2. So in sequence 1, what is happening? Initially, we are told that semaphore X is 2. It's a counting semaphore. Semaphore Y is 0. Is it also mentioned that semaphore Y is a counting semaphore? That's a small catch. Yeah, it should be mentioned because X is initialized to general semaphores. Probably we should have just said, okay, counting semaphores. Okay, general or counting semaphores. Because some people could get confused and say, hey, X is initialized to 0, which means if it's a binary semaphore, what happens, right? So probably a small change here. I just thought about it while solving it myself right now. Cool. So let's get into it. It's very simple. This is your sequence 1. This is your sequence 2. Let's look at sequence 1, right? Semaphore X is 2. It's a counting semaphore. Semaphore Y is 0. Then, so you have A1, then A2, B1, A3, B2. We've just put numbers here, right? So PX basically, P basically means down. V basically means up. So PX basically makes this 1, right? So Y doesn't change. We're just executing each of it in a tabular manner just to make it easier for us to understand, right? You can do it without even drawing this table. This only eases the explanation. Then you have Vy, right? Vy is basically up. So whatever is 0, this is up to 1, right? Simple. This is executed. Then A2, P is again down in X. So X goes from 1 to 0. This is Vy, which means Y would get incremented. Cool. Very good. Then AA, then you're executing B. B is Py. Remember, these are counting semaphores, right? So their values have to be greater than or equal to 0. They can never be negative, right? They have to be greater than or equal to 0. They can't be -1, -2, etc. So you have Py here. So if you notice AAB, this is also same, this is also same, right? So AAB is the same in both the sequences. So in this sequence again, Py, P is basically down, right? So this goes down, nothing changes in X. Then again Py, so this goes down. Then Vx, V is up, so this goes up. Then you have Vy, Vy basically means this goes up. Simple operations. Till here everything is cool. So AAB is executed. Now we have two options, AB here and BA here. Now let's see what happens if you have AB. Okay, cool. So with AB, what do we do now? PX is there. Okay, so PX basically means X is going to get down, right? X got decremented. Vy, which means V is going to get incremented. No issues. We are not going below 0. Everything is greater than or equal to 0. So this is also perfectly all right. What happens with B2? Py, which means this is going to get decremented. Again Py, so this is going to get decremented. Vx, which means X is going to get incremented. Vy, which means this is going to get incremented. Final values of the semaphores are 1 and 1. Perfect. No inconsistencies here. This is perfect. S1 is perfect. What happens to S2? This is where things will get interesting. In S2, after this line, look at this. After this line, we will execute these 4. Right? So what is the current value? So let me use a slightly different color here. We have 1 and 1. Right? On 1 and 1, we have Py, Py. So if you do a Py on this 1 becomes 0. When you do the second Py, you can't decrement it to -1. This is not valid. Right? You can't decrement it any further. So the moment you have this, you will have a problem. Right? So this second Py, so in this sequence, AAB, then you have the second B. In the second B, when you execute the second B, you started off with 1, 1. This whole thing is not there, right? You started off with 1, 1. You decremented this 1 to 0. Then you're again trying to decrement it, which will simply block and fail, right? So this sequence is not possible. You cannot execute this sequence. So S1 is true, S2 is false. Now if you see that S1 is true, S1 is possible, S2 is not possible. So this option is correct. And which of the following is the incorrect option? So A, C, D are incorrect options. Very simple. Simple question. If you just know these basic operations, simple question. This is actually while this might be a medium level 2-mark question by gate standards, this is simple, right? If you know what up and down do or P and V do, it's as simple as that. Cool, with that out of the way, let me just change the screens quickly to our to the video system, and let me tackle your questions now. Cool, okay, I'll just pick my phone. There were a couple of interesting questions that I saw. Okay, couple of interesting questions that I just saw a while ago. Okay. So Bitu, you have to watch the course videos, please, or you have to learn how semaphores work, because I'll not be able to explain why semaphore can't be negative in this context, right? Again, if you don't know the concept, participating or trying to answer these questions may not be very helpful. I strongly recommend, our fundamental assumption is you know the concept, right? We'll try to clarify some of the follow-ups, but we assume that you know the concept before this live sessions. Cool. Where are we? Let me just, again, please put your questions in the chat window, the general questions that you guys asked me a while ago. I'll try to answer as many as possible. Okay. Oh, okay. This is a slightly personal question, but I'll answer it. So I did wanted to pursue a PhD at some point, but ever since my undergrad days, my objective was I'll join for a PhD, do some interesting work in AI. I didn't know about other areas. I mean, I was very much passionate about AI in my third and final year, and I thought at the end of it, I wanted to use IISc as a stepping stone to go to a top university, probably do a PhD there, and then do a startup based on my PhD thesis. But then at IISc, I realized that because I didn't know what a PhD truly means before I joined IISc. So at IISc, I learned that PhD is more about taking a small problem and pushing the boundary a little, rather than trying to get an exhaustive real world experience, which you typically don't get in PhD. And to do startups or to build companies, what is required is a more exhaustive knowledge, both from engineering, science, research, people management, product management, program management, all of that stuff, which I realized I may not be able to learn everything in a PhD. So I ended up joining in a job. And I was very fortunate that at least at Amazon, when I joined, our team was so small that I ended up doing all of these things. I did everything from product management, program management, product development, writing software engineering code, designing software architectures, of course doing a lot of machine learning, data science, etc. So that gave me a lot of real world expertise on how to build things from scratch. Anyway, so let's get back to the actual questions from the students. Cool. So colleges have reopened. So we have morning 4 hours and evening 4 hours. How can I use them effectively? I have finished the syllabus. Very good. Very good. I'm in a position to revise one subject notes in 3 hours. Terrific. Terrific. So Gautam, my suggestion for you is every day, probably the early 4 hours, try and finish a subject. The evening, maybe 2-3 hours, try and finish all the topic tests and subject tests and grant tests as much as possible. And use the remaining time to debug what mistakes you made and to fill in your gaps. Maybe one day you can finish a subject, second day you can debug your whole mistakes and try to fix the bugs that you have. It could be silly mistakes, it could be conceptual gaps, it could be lack of revision sometimes, right? So do that for a few days, you'll finish all the subjects quickly in a month and then go for full length grant tests. Try to fill in all of the gaps that you have and the silly mistakes that you're committing. You're on a terrific path. Okay, so this is from Soham, who says, I'm completing my whole syllabus by the end of this month. October and November for subject and multiple tests. December for mock and full length tests. Very good. Soham, very good. That's a terrific plan to have. I'm happy that some of the students are completing the syllabus. But most importantly, nobody gives you bonus points or brownies if you complete the syllabus early. We have seen a lot of students who completed syllabus early but did not do. I'm just warning you. I'm not discouraging anybody here. I'm just trying to give you a realistic perspective. Please take it constructively. So the important thing here is all the gaps you have, fill them. Because somebody who is not finished, we have seen this last year and the previous year also. Some people complete the syllabus in a hurry. They have a lot of gaps that they need to still work on. While others take a lot of time for their first iteration, but do it so thoroughly that the second iteration becomes trivial. So ask yourself where you are. If you have done your first iteration thoroughly, great, like kudos to you. But please try and plan the rest of the 5 months that you have thoroughly. You have like 5 months, 1 week, roughly, give or take, right? So please make the most out of it, plan it accordingly. If you're finishing the syllabus, great. Fill in all your gaps, solve as many problems. If you have time, solve previous year questions also. Solve as much as possible, debug your mistakes. That's the key. Cool. Okay. So this is Korla who says, I'm a second semester student. I'm planning to prepare for GATE 2022. Okay, from 22 to 24. Okay. So okay, and you have a fear of missing out on doing programming. So since you're very early in your BTech, right? Please spend the first 2 years becoming good at data structures, programming, competitive coding. Those problem solving skills will help you immensely. Learn data structures, discrete mathematics. These are fun subjects, right? So spend the first 2 years becoming a good programmer with good, strong knowledge in data structures, algorithms. Also learn the other subjects that you have in undergraduate studies for this. So for 2024, which is still some way, third year, crack your GATE. Because if you have done your problem solving thoroughly in the first couple of years, crack your GATE in third year. Fourth year, you have all the time to do some great projects, prepare for some great placements and things like that. That's what we would recommend for somebody who is just starting out, who's probably in the first year of their BTech or second year of their BTech. So Sakshi says, I'm still left with 4 subjects. What should be my strategy? Simple. 4 subjects, right? Roughly it will take you like what, 3 months max, even if the subjects are lengthy. I'm assuming the subjects could be slightly lengthy. Try and finish everything in about 2.5 to 3 months. So your September, October, November. By November and early December, you should be able to finish it. Right? Realistically speaking, even if the subjects are slightly lengthy, try and finish it by November and or early December, and use the 2 months from early December to 2.5 months that you have. Try and put all your energies in, again, the second iteration, which is solving mock tests, grand tests, subject tests, multi-subject tests, previous year questions, etc. Cool. Okay, so this is from Nagasai. So I'm a final year student. I got an internship. Should I focus on internship or completely focus on GATE prep? This is a slightly tricky thing. I understand that an internship will open doors for a pre-placement type of offer, like a job offer. You also have GATE. As long as you can still put dedicated effort, like 4 hours a day on your GATE prep, it's perfectly okay to go for an internship, because when you're doing an internship, you don't have the regular college coursework, right? And we see a lot of working professionals who do that. Internship also gives you some real world skills. It will also probably help you get placed in case you don't get a good GATE rank. So, and expectations from interns is also not that high, typically in most companies, right? So I would say go for the internship, learn a little bit there, but try and make sure that you're at least putting in 4 hours a day, maybe a couple of hours in the morning, couple of hours in the evening, whichever way. Make sure you're putting in that effort, otherwise your GATE goes for a toss. As long as you're putting in that 4 hours a day, internship should not be a problem, because there are so many people who are working on full-time roles. So there is no scholarship test. We are conducting only one scholarship test a year. So next year again, roughly at the same time, again, depending on the COVID situation then. So next year, for the next year GATE, there will be a scholarship test. We don't have any more scholarship tests because we try to conduct one solid test and accommodate as many students as we can. Cool. So Tanya says, I have an interview with SAP Labs tomorrow. I have not prepared C++ and Java. Should I skip it? Please don't. For heaven's sake, please don't skip your interviews. SAP Labs is a pretty decent company. Please give an interview. If the interviewers ask, you can revise if you already know C++, right? How much time, or Java, right? How much time does it take to revise the object-oriented programming concepts? You can do it in like 4 or 5 hours. After this live session, sit for 4 or 5 hours. Go through any decent online resource or pick up a standard textbook for C++, Java. You can revise all the, that's a fundamental difference, right? It's object-oriented concepts. And you can quickly revise them in like what, maximum 4 or 5 hours with a bunch of examples, and you're done. Please don't skip interviews, for heaven's sake. Please don't do that. You can easily revise this. So Arjun says, I got a job, joining is Jan 2022. Should I take the offer letter? Yes, you should. Just talk to the company and say, hey, can I join on February 15th or so? Just talk to them. Most often companies will be okay with it. Just talk to them and say, hey, I'm writing this examination. I have this so-and-so deadline. But it'd be okay if I join 45 days late. If they say yes, go. Even if they say, no, you have to join. In the first 1-2 months, right, you're just getting onboarded. You'll have a lot of bandwidth. So don't worry about that. Don't skip your job because it could so happen. If you don't get a good rank in GATE, what happens then? You've lost a terrific opportunity and you'll have career gaps, which is never good. Okay, so join or else request them. Most companies will be okay with it. Okay, cool. Has any exact question come in GATE which is covered in your live sessions? We have seen this with some of our test series questions. Not in the live, of course, test series and live sessions have some overlaps because most of the professors at IITs or IISc or even at NITs who actually make these questions, they use the same textbooks. They use the same exercise problems, semester end exam problems, midterm problems from their universities and other universities. Because that's the easiest way for them to create questions. They might change a few numbers here and there, wording a little here and there, but we all use the same resources at the end of the day. So we have seen a few instances where that has happened. So this is Dhruv who says, I've completed all subjects except maths, COA and DLD. Simple. Finish DLD first. Because DLD is easy. Very easy to score, very simple stuff. After DLD, finish math because math has a lot of weightage. Finish all of your math, engineering maths, discrete maths. At the end, do COA because COA tends to be slightly harder to score marks in. Again, this is students' experience. We still think COA is very scoring. But do math because math has, the engineering and discrete math has more weightage. Finish that, then go to COA. You can finish all this in like maybe 2.5 months max. Again, Akash, please don't drop your preparation now because you've already put in effort. Again, this is very common that happens to everyone, that they get overwhelmed as they're coming closer to the examination. They feel that they're not ready. Please don't give up. We have seen people start their preparation in late August and early September last year. I'm sorry. We have seen people who started their preparation very late and still have performed terrifically well. So giving up is certainly a bad idea. It basically means all the effort you've put in, you're just draining it off without actually taking it to a logical conclusion. Please don't leave it. So, okay, so Mohan is asking about one of the projects that we uploaded recently as part of our exam prep. So that project is basically, there are 2 parts to that project. In the first part, we introduce some basic linear algebra, some basic machinery, some basic code libraries, Python obviously, to build a apparel recommendation system using both images and text, using actual data from Amazon.com itself. So we walk you through the step by step. We'll build the mathematical, there'll be some basic linear algebra concepts that are used there. We'll explain those concepts, we'll explain the code, we'll explain simple libraries, all of that stuff. That's the first part. The second part is slightly advanced. In the second part, we take these concepts and then we explain you what is containerization and Docker. How do you design a solution? How do you design the high-level design of a system? Also called a system design, right? So here is a problem that you're solving. How do you design the high-level design or system design for this problem? Then how do you use something called as containers or containerization and Dockers, which are very, very popular technology used in actual real-world implementations. Like a lot of state-of-the-art machine learning and deep learning and computer science stuff, highly scalable CS stuff that is actually deployed in the real world is built on Dockers and Kubernetes and things like that. So we introduce the concepts. Then we explain about something called as Elasticsearch, which is basically a distributed inverted index system. We give you an intuition how it works. We connect it with hash maps. So we give you that. And then we talk about how do you build the whole system? How do you deploy it? How do you measure the latency of the system? How do you make sure that you're building a low latency system and things like that? So there are basically 2 parts. There is a basics part where you learn the mathematics, where you solve a problem, where you write code to get it to work. Simple solution, but we also recommend students to go to the advanced section. The advanced section has all these more advanced concepts like containerization, inverted indices, Elasticsearch, etc. That's one of the first case studies that we've done. The second one we'll probably upload in a day or two. That is more about how do you build a desktop search, right? So let me just show it to you. So I mean, you can go to your Windows search, right? Or your Mac search or Linux search. As you type something, or even on your phone, right? If you type something, it will start searching on, all the contents of your phone. So how do you build something like that? There is a design aspect to it. Again, we'll introduce you to some interesting concepts, again, like inverted indices. How do you do tries, right? So we'll do all of those basic stuff, and then we'll discuss about how do you design a solution, what are the business constraints, how do you satisfy the business constraints, how do you ensure that you're not eating up too much memory, how do you ensure that, suppose if your index is too damn large, how do you store it in RAM? Because for a problem like this, your index can run very, very large, but you still have to run it both on, like we'll discuss about what are the challenges on running on a smartphone, what are the challenges on running on a desktop, right? The actual engineering challenges. You want something to run very fast. So all of the engineering challenges we'll discuss, we'll see how to solve each of them using techniques that you learn in GATE. It could be concepts from operating systems, it could be concepts from data structures algorithms, it could be concepts from computer networks, right? It could be concepts from, not so much, computer networks we use it when we explain about Dockers, etc. But for a desktop search engine, we typically use data. How do you use databases smartly here, right? And what are some interesting NoSQL databases? What are some interesting advanced data structures like tries that you can use? What are the pros and cons of each? Okay, that's what we try to do in this. Cool. So again, in our placement prep, what we have is, you have all the data structures algorithms, and then we have 200 solved problems from companies like Amazon, Google, etc., top product-based companies. And we have 300 practice problems, and we use HackerRank as a platform where we have created all these questions. All registered students get enrolled there because HackerRank is a very popular platform, actually used by a lot of companies for hiring. So we thought, why not have our own HackerRank system for students to explore? So we have 300 practice problems there, and we have these projects. Cool. Again, back to the discussion here. Okay, so Anirudh says, I have a backlog and I'll only be sitting for placements in November, so focusing on GATE for now. Should I focus on practicing programming also to try off campus? Yes. Please understand that if you know the GATE concepts and if you have basic programming skills, you can crack most off campus, especially at services companies or even product-based startups. The large product-based companies like FANG companies, they have a slightly higher bar for data structures, algorithms, and problem solving. That you can certainly prepare, right? I mean, if you want a publicly available resource, just go to LeetCode. I really love that platform. It's a great platform to solve problems, or HackerRank, right? Great platforms. Cool. Again, any issue that you have with the course, just call us on the phone numbers listed on our website. If you want to escalate anything, that's the fastest way because it typically goes to one of our co-founders or the key mentors, and we will resolve it quickly in case there is any problem. Okay. So this is from Pradyum, who says, how are 40 marks in final grand test? It's slightly on the lower side, realistically speaking. So again, I'm assuming that you've just started taking your grand tests and you're getting about 40 marks. That's surely on the lower side, but that happens. Don't panic about it. Don't worry about it. Since you have about 5 months, try and push that 40 up. We've seen a lot of people who got those 30, 40 marks in the first grand test that they've taken who are in top 100 ranks. It's very, very doable. The strategy is revise your subjects better. Go back to the mistakes that you have done. What are the 60 marks that you have lost? Debug every question, make a note. If it's silly mistakes, double, triple, make a note. If it's conceptual gap, go back, revise. So we have seen students go from 40 marks to 45, 50. Slowly they'll keep pushing it. By the time they come to Jan, Feb, by end of Jan, they typically push it to a larger number like 70 plus or even 75 plus. Okay, so it's very doable. Again, somebody is asking questions about applied AI course. I think it's unfair for other students who are here, but please email us to the email address that you have at applied AI course or call us. We'll help you there. So another question here is how to revise one subject a day. So my suggestion is this: once you are doing your first iteration of subjects, you can use the notes that we provide. You can make highlights in it or make your short notes. So assuming that you're planning to put in 3 to 4 hours a day, you should make your short notes. Everybody has a different strategy. No people write the short notes the same, right? So oftentimes we see, especially working professionals who are constrained on time, they just take our notes, they just make highlight, they just print it out, make highlights, and just write short scribbles on the side. They just revise that. That's perfectly all right. No problem with it. That's what I often do. I just scribble on it, scribble on the right side of it. So that's perfectly valid, perfectly fast way to do it. So do that. Make sure whatever short notes that you have, you can revise it in 3 to 4 hours. That's the strategy. Okay. So, okay, this is a nice question. So, can we place this apparel recommendation system using images and text in your resume? No, because you have not done it. That's the important part. But what we have done here is, after explaining some of the basic concepts, we give an exercise problem. We give an exercise problem, solve that exercise problem, which is a slight extension to what we have discussed. That extension, you can place it in your resume. Please don't put anything that you have not written code from scratch yourself in your resume, because the interviewer will quickly find it out and say, hey, you're a fraud. Very easy. Please don't do that. So any problem that you want to solve, even the case study problems, take the problem, understand the problem. We'll give you some extensions. Solve those slight extensions. We have done it both for the basic solution and also the advanced solution. Implement that small extension as an exercise that we have, or we call it an exercise or an extension. Solve it. Write a nice technical blog about it, put your code on GitHub and put it on your resume. That's great. But don't just copy paste the code, because people can quickly Google search and find that, hey, this is available in Applied AI course, right? Or this is available in the placement prep course. I'm sorry, not the Applied AI course. Okay, so this is a question about quantum computing at IISc. I think the quantum computing, again, I'm not fully well versed with the quantum computing program at IISc, but my initial thoughts were, this is a program that is offered by the Quantum Computing Center, but it's more on the physics side of things, on building the quantum computational infrastructure, on the actual physics side of things, not so much on the computational side of things. I'm sure there might be a professor in one of these departments, either in physics or in computer science or in supercomputing or in the Center for Data Analysis and Computing. So I'm sure there will be one professor or maybe multiple professors who are working on quantum computing itself. That is perfectly all right. But a master's degree or a PhD in quantum computing, if I'm not wrong, the quantum computing lab comes under the physics department. Again, you'll have to verify it, because I'm sure things would have changed a lot now, right? So please go to the quantum computing department website, see what are the courses they have, who are the professors who are conducting these courses, what departments they belong to, so that you know what the course will be. Or else you can always reach out to the department email address or currently students who are pursuing to understand who this is apt for, because that's something that you have to look at. So what's your opinion on masters in Germany? Again, Germany has a lot of universities. There are some phenomenal universities like TUs, right? So if you're going into some of the TUs, I don't know what the full form of it, technical university, I mean, it's a German name. So as long as you're going into the top 10 universities in Germany, they're great, no doubt about it, right? There is also, if you want to go into more research places, there are these Max Planck institutes. Those are also terrific. They're like IISCs of Germany, hardcore research institutes. Like Max Planck, there are multiple Max Planck institutes. Think of it like IITs, but for different areas. So if you go to one of the Max Planck, I know a lot of professors at IITs and IISc who have done their postdocs or PhDs at Max Planck institutes. So they're a terrific place to go to. Cool. One second. So this is a nice question. This is from somebody whose alias is Nerf Herder. Is there a correlation between the All India mock tests and the actual ranks in GATE 2021? There is some correlation, but there is also a lot of noise in that correlation, because we have seen some students who got very good ranks who did not get a good rank in GATE 2021 because they simply messed up the paper as soon as they saw a few tricky questions. We also seen the other way. So while there is some correlation, it's not a very, very hard correlation. It's a very soft correlation. I didn't measure the rank correlation coefficient between both, but my gut feel is it's not going to be very high, because the reason being that students in the examination hall, based on the set they got, they messed it up last time especially, right? So Sahil, you can just print the notes that we have on our website and use it. That's perfectly all right. It's easy to go, easy to use, no issues with that, right? You can just do that. Cool. I think we've touched upon multiple topics, a wide variety of topics, and thank you very much for attending this live session. Again, see you the next Tuesday. All the course enrolled students, see you the coming Friday for the next live session. I think the next live session is also on operating systems, if I'm not wrong. So we will probably wrap up operating system with one more live session and start the next subject, right? So all course enrolled students, see you via Air Meet on Friday. All students on YouTube, see you on the coming Monday. Thank you very much. Bye-bye.